Hello everybody and welcome to this My Corner of the Internet. I am SD-Card and this is the 6th episode in my series on OCI GCSE computing. So today we're going to talk about networks. So yes, this is a really long chapter, not because it's got loads of points in the syllabus, but because there are a lot of whats and whys, and when I've translated them into questions and they've come out as lots of whys and things. So, yes, very quickly. So, starting off, what are the advantages and disadvantages of creating a LAN? So, a LAN, if you don't know, is a LAN. If you don't know, stands for Local Area Network, and it covers a very small geographical area and allows you to share files with people in the area. It allows multiple computers. It can allow multiple computers in an area to access the same same database. So this is important for businesses and things, so that they can have one central computer with all the checkouts and things connect to. It also allows multiple people to work. On the same file. So let's say you have a Word document on a server that multiple people can access at once. They can all adapt that and do stuff with it. It allows people multiple workstations. So each computer on a network is called a workstation. You need to remember that. So each workstation on a network can access all the other peripherals on a network, things like the printer, maybe a monitor or projector or something. All of that can be connected to the network that different workstations can then access at once. It also saves space on computers, because instead of installing the same software maybe 200 times across all the computers, you instead install it once on a central server that can then be connected to over the LAN and used on every computer. Okay, so finally, networks allow administrators to limit what people can see, so like it protects the information. So for example, there's no need for a person in research and development, so R&D, to look at everybody else's accountancy information. Okay, so on the other hand, however, to create and maintain a network, it requires experience and skills. The administrator needs to have the ability to do so. And it is actually in a company, the network administrator is actually a separate job all for itself that people are paid to do. It also has major security flaws, so for example, once a virus is installed on one computer, it can easily jump from workstation to workstation and just cause complete havoc. A hacker can also easily access the network, especially if it's a wireless network, so they don't actually need to be in the area, they can just connect to it over the internet. And if there isn't a clear set of security measures, infiltrators can easily come in and pull off complex social engineering scandals, so I'll cover more of that later. Okay, so components you need to set up a LAN. So a network interface card, or NIC, is the thing that creates the signals needed to send information over a network. So these days they're actually usually built into the computer. However, you can also get plugins and things for USB adapters and stuff that all do that kind of thing. Next you have a terminator, which is something that's unique for a bus network, which we'll cover also later, and it basically prevents data reflecting off the end of a network. So which then reduces the number of data collisions, and that helps with the integrity of data files. Okay, so next you have repeaters, which, like in Minecraft, boost signals along a wire. Sorry about the reference there. Because the longer the distance that a signal has to be transmitted along the wire, the more integrity it loses. So therefore, you have to have repeaters. So if you're extending a cable a long distance. So hubs are then multi-output repeaters. So they allow multiple workstations on a network to connect to access a network at once. Next, you have bridges, which do what they say on the tin. They transfer data between two different net segments of a network. So let's say you have a campus-wide network, and you have different sections of that network. For maybe one for the DT part and one for the IT part. They may need to be able to communicate at some points. Therefore, you have a bridge between the two, which will connect them both. Okay, a switch is then a high-speed bridge that uses a dedicated CPU to perform switching operations, so it helps decide where to send the data. Then routers are the interface between two different networks, such as between your home network and the internet. Okay, so next one's types of networks. So you have there are two overarching types, which are peer-to-peer networks and then client-server networks. So a peer-to-peer network, in a peer-to-peer network, all the computers are equal. They're all administrators, and they all can take charge of their own settings. They all have the same privileges. They often use a hub in order to connect all the computers together, and on a peer-to-peer network, you can access them and access each other's computers. This is usually for a home internet system. So people can access different computers in their home through their network, as long as they have a password. However, they can quickly become chaotic because of all the data being sent around, and people having to maintain their own computers. And having to make sure the internet connections, network connection stays strong. There is no network-wide security, so people can easily infiltrate it and just muck about with stuff. It's also very difficult to keep track of it because of all the data going around. Another important thing to realise is that the more people accessing a computer on a peer-to-peer network, the slower that computer will become. So, yes. Then you also have client-server networks, which is where these are most commonly used in organisations, and basically one or more servers provide services to each client. Okay, so each workstation on the network is a client, and they connect to the server to get information off them. They have better security and better performance, and they are also easier to back up and maintain. It also makes it easier for software updates, because instead of having to install loads of updates on those computers, you just install the software on the server and then update the software version on the server. However, the system administrator does need to know about networks and set up and enforce certain security measures. And if the server malfunctions, more data is lost than if it was just a simple peer-to-peer network. Okay, there are three different main network layouts, and they are bus networks. You have the bus network, you have the ring network, and you have the star network, and these are different network topologies or different layouts. So a bus. Yeah. Okay, sorry, getting a little bit lost. Okay, so this is a bus network. So a bus network has a single main cable running throughout the entire network, to which all the devices are connected. So whether that is a computer or workstation, a server, or a peripheral such as a printer. There are then terminators at either end to prevent data bouncing up and down. And yeah, it's possibly one of the most basic setups, and it's most useful for small operations or temporary networks. So a computer sends data along it by sending data both ways along a node on the network will send data both ways along the cable, and then and that data will continue to exist on that cable as long as the terminator doesn't destroy it, or it dissipates or is absorbed by another node. So yes, the downsides of the bus network are that it can only one of the nodes can be sending or receiving data at any one time, and also if the main cable breaks, then the entire network goes down. Okay, so ring networks are then fairly similar. Each device on the network is connected to the next one in the circuit, usually in only one direction. And if you send data through the network, it has to go through each and every computer until it reaches the place where you're sending it to. This has certain downsides, such as, let's say your computer is the one after the printer in the ring. The file you want to have printed has to go around the entire network to get to the printer. So yeah, let me think. The data must go through each machine to get to the destination. Also, if any of the cables break, then the entire network goes down, because there's no backup. There's only one route for the data to go. That is the defined route. You finally have the star network, which basically which is possibly the most common, especially in schools and organisations and things. And okay, so all the devices on the network are connected to a central switch or server by a dedicated connection, and the switch receives the information and sends it where it needs to go in the network. It can be difficult to set up, however, it has the best performance out of all the networks. And also, if a cable breaks, it doesn't necessarily mean the entire network goes down. So let's say one of the cables from one of the switches to a computer to a workstation goes down. That's it. That cable's broken, but the network continues to continues to work. Yes. Yeah. Okay. So difference between a LAN and a WAN. Okay. So as I said before, LAN stands for local area network, and that basically means it covers a small geographical area. A WAN is a wide area network, and it's basically a series of interconnected LANs, and most common example I can think of is probably is the internet. Okay, so again, moving on. So network protocols, are network protocols are a set of rules or standards that manage how different workstations on a and devices on a network communicate. Possibly the most common is TCP/IP. So TCP/IP. And that basically allows different types of networks to communicate, and it's the protocols that are most commonly used for the internet. On a TCP/IP network, each of the devices has an IP address, and each computer has a unique IP address, which is 32 bits long, and yeah, it usually changes between times you log on to a network. However, you can specify that you always want the same IP address. Okay, a MAC address, or a Media Access Control address, is a unique identifying code that is hard-coded into a network-capable device by the manufacturer. So it is built into the computer. And it helps the router or the switchboard identify devices on a network. Okay, then finally, a packet is a bundle of data that's sent over a network. So not all the data for a file or instruction can be sent at once, because it'd be massive and it would take up all the resources on the network, and so the file is split up into packets, and those packets are sent over, and it allows multiple people to use the network at once, as this network switches between dealing with different people's programs. Okay, so the more packets traveling on a network, the slower the network. Okay, so security, as I mentioned before, is a very big must for a network, seeing as networks allow multiple people to access the same data. The lowest level of security is to have a user ID and password, which basically means that only people with a username and password are able to log on to the network and use it. I plan to show you a website, but yeah, doesn't matter. Usually a very strong website would be strong website. A strong password would have both letters, numbers, and special characters. By that I mean things like the @ and percentage signs and things. But I don't advise using the £, as some websites don't recognise it, and it varies across computers. Users can also be assigned access levels, so they can only see the data on the network that they are required to see as part of their job. So again, referring to my previous example, why would somebody in R&D need to see the accountancy stuff? Finally, we have encryption. So this is the use of algorithms and processes to encode data in a way that it isn't easy to read. So if an encrypted file is intercepted by a malicious user, it is difficult for them to read unless they have specific software that allows them to decrypt it, or maybe if they have the same software on the system, they still need to have the correct key in order to decrypt the file. Okay, next, so most computers actually have security measures called acceptable use policies, which employees must sign up to in order to be able to use the network. These lower the likelihood of a successful social engineering attack. So a social engineering attack is when a person actually doesn't necessarily hack into the system using code, but manipulates people in order to get onto the network. So this can actually either be simply impersonating somebody and phoning up, or sometimes even actually going into a company and asking, can I please have a new account? Saying something like, I'm new here, can I please have an account for this software? I've been told by so-and-so to come and see you. And the most common social engineering attack is phishing emails, which is the kind of thing where you get emails from apparent long-lost relatives who want to send you a newly inherited fortune. Don't do it. So yes, the rules the acceptable use policies must be signed up to in order to access the network for most companies. And basically there are a set of rules that stop the likelihood of hacking to occur, and they include rules such as to use polite language online, to not reveal any personal details, to not send personal mail through the school, personal emails and stuff through the network, to not send offensive documents or use the network for personal financial gain, and not defaming people, and not to actually download any programs. Okay, so you then have failover protocols, which a failover protocol is a rule that is a set of rules that are set up so that if the primary network goes down, your computer will switch to using a secondary network so that it can carry on working as normal. So systems also regularly backed up, meaning that a copy is made of the memory of that device so that if something goes wrong, it can be restored. And so if you have a server and all people's data is stored on the server will be backed up and things like that. And then that backup will then be stored in an archive. And the archive basically is a set of different backups from different points in time that the system can be restored to. So let's say that that a virus has been sat on your system without your knowledge for the past on your server for the past week. You haven't noticed, and you've been just doing regular daily backups. Then the virus reveals itself, and everything goes haywire. You can then go into your archive and restore the server to a point previous to when the virus was installed. Okay, so all of this is part of what is called disaster recovery. So this disaster recovery is a plan put in place in case of a disaster, whether that is man-made or natural, so things like an earthquake or a fire, or maybe even just a virus coming onto the system. And they usually split into three parts. So prevention, which is things like the acceptable use policies, which basically which enforce the use of common sense amongst employees and things. Then there is detection, which is things like antivirus software and virus detection stuff. And then finally you have correction, which is restoring from backups and archiving and things like that. Okay, moving on to the internet. So you have the definition of the internet on the syllabus is very specific. You have to know this definition. The internet is a worldwide collection of computer networks. Okay, so it's a worldwide WAN of LANs. Okay. So there are different components that are needed for the internet. So when the internet was first created, you would have to have a modem in order to connect to the network. And a modem, the job of a modem basically is to convert digital data into analog data in order to transmit it across a telephone wire. Okay, and then these have been slowly replaced by routers, which connects a LAN to a digital transmission device, which then broadcasts to the wider internet. Okay, so the router's job is basically to decide where to send the data that it receives, whether that is back into the network, in through the intranet, or infranet, but no, it is intranet, or to send it to a specific internet server. Okay, so each resource on the internet, each server, each web page has its own unique IP address. So this is kind of like your own home address. So it's unique to you, and it helps people send things to you in the mail or through, just mail basically. However, this 32, as I said before, an IP address is 32-bit long code that is used to identify a resource. However, IP addresses are fairly complex to remember. So, and it's fairly annoying to have to type a long list of numbers into your web browser when you're trying to access a web page. This is where the DNS comes in, so the domain name system. So each website is assigned an IP address, and the IP address is then also associated with a domain name, so the traditional www.something. So there's .com, .org, .co.uk, that kind of thing. So when you type in a domain name into your web browser, that domain name is then sent to the router, and then the router sends the domain name to a DNS server, so which then translates the domain name into an IP address, and then it finds the IP address and the device associated with the internet resource associated with that IP address, gets the data from it, brings it back, and sends it to your computer again. And the domain names are used rather than IP addresses because they're easier to remember. So instead of remembering a long list of numbers, you can remember something catchy like www.google.com. That's a lot easier to remember. Okay. Most web pages on the internet are written in HTML or hypertext markup language, and it's used because most web pages use it. It was the first language dedicated to creating web pages. It was actually first created by Tim Berners-Lee, the creator of the internet. And as I said, it's used because it is used on web servers. It is a de facto standard. Remember that from the fundamentals episode. So it's also simple, and it allows anybody to create a website if they wanted to. Okay, so there are different file standards for transmitting data across the internet, and these are some common standards are JPEG, which I didn't know some of these, what these stood for before today. So there are JPEG, which stands for Joint Photographic Experts Group, which is commonly used to send image data. Then you have GIF, or Graphic Interchange Format, which used again to send images, but most people use it is to send animated images. You have PDF, which is Portable Document Format, which is used to send images and written documents. Then you have MPEG, or Moving Pictures Expert Group Format, which is used to send video. So I don't think this video is recorded in MPEG, but I have the choice to. And then finally you have MP3. This is being more replaced by MP4 now, but MP3 stands for Moving Pictures Expert Group Audio Layer 3. Catchy title there. All of these have different compression techniques. So you have and data needs to be compressed if it's going to be transmitted over the internet, because there is so much data. It needs to be made smaller so that it can be cut up into fewer packets so it can be transmitted faster. The better something is compressed, the faster the download speed for your browser or computer, so that then you can get to see it faster. So there are two main types of compression, and those are lossy compression and lossless compression. So lossy compression is the removal of data from a resource, so that it reduces the amount of the file size, and the data that's removed is data that our human senses wouldn't normally pick up anyway, so there's no point there being it. So it's like dropping the bit depth or color depth of a image, reducing the sample rate of sound of an audio file, or maybe even reducing the video quality of a video. Loss, however, is more common to want to keep all the information stored. This is where lossless compression comes in. Yeah, there you go. And basically, lossless compression reduces the packets needed without losing as much data. So here I have an example of compressing the text "Hello World." So the most common way of lossless compression is to put all the different types of things you'll need for the file into a list, assigning each different item a number, and then simply sending the order of numbers that appear. So the example I've got here is "Hello World." So there are 10 different characters used, and so you've got 0 is H, 1 is E, 2 is L, 3 is O, 4 is comma, 5 is space, 6 is W, 7 is R, 8 is D, and then 9 is the exclamation mark. And so then what would then happen is that instead of sending all the data, you would then send those numbers in the order that will appear. So hello world, compressed through lossless compression, would so you'd send HELO comma space WRD exclamation mark, and then you'd send 01223456372889. The computer at the receiving end would then sort that out. It would then put the different items in the order of those numbers. So you still result with HELLO comma space WROLD exclamation mark. Okay, actually, didn't realise it, but that brings us to the end of this section of the section on networks. Again, it's only taken us 31 minutes, but hey, as I said, I apologise for length, but there's nothing really I could do about that. So if you found this video helpful or interesting, make sure you like and subscribe. If you know somebody who would find this interesting or helpful, make sure you share it with them. At this moment in time, the exam is in less than 5 days now, actually. So no, it is in 5 days' time, actually, including today. So they will probably hug you if you send them a resource to help them with this problem. Maybe you don't want them to hug you, but I don't know. So yes, other than that, thanks for watching.